How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be continuing our discussion on MPLS VPNs. We're focusing on the MPLS part of the VPN. VPNs will come later on. What we're going to be doing in this video is we're discussing LDP, Label Distribution Protocol, and how it works. So just to catch you guys up, we have completed the IS to IS configuration. So if you went through the IS to IS section and you went through that video on how to configure IS to IS, and then you watched the video before this, you're like, it looks like the same video, and it's because it is. So I repurposed the video just so that we would have it, twice. So it was the same config, just so it was a reiteration, because it is the IGP piece to the MPLS build out that we're doing. So in this video, we're going to now take it into how do we leverage the IGP to do label distribution and go from there. So I'm going to walk you through the configuration and discussion of how all this stuff works. So what I'm going to, in this video, we're going to be talking about what you can do to enable LDP and how it works and all that type of stuff. And so as we get through this video, that we'll have LDP stood up at the end of the video and go from there. So without any further ado, let's go ahead and dive into this. So first and foremost, we have label distribution protocol. So from a discovering neighbors perspective, like IGPs, LDP automatically discovers neighbors with a hello protocol. So it uses multicast UDP in order to do its thing. And it uses the 224.0.0.2 well-known multicast group for the all routers multicast group. So you have 224.0.0.1 is all hosts. So if you were to be on an end station, I don't know if it will actually work if I do this. I haven't tested this out. But if I was to ping 224.0.0.1, the intention, I wasn't sure if that would actually work or not, is the idea would be to ping all the endpoints on your network, which is going to be your computers, laptops, printers, things like that. Where all routers multicast is focusing on intermediary devices, stuff like that. Now, LDP uses the source and destination port of 646. And you'll see that 646 is used for both the discovery and for the transport of the communication of LDP between devices. The hello includes the IPv4 transport address to use for the TCP session, which will defaults to the LDP router ID, which should automatically be the same as the IGP, and we'll be able to set the LDP router ID when we get there. And it forms a point-to-point TCP peering. Now, when it comes to actually forming adjacencies after you've discovered your neighbor, you're going to form an adjacency with them. LDP sessions are formed reliably over TCP using unicast between transport addresses. Again, this is going to be, typically speaking, you're going to be using loopback to loopback. However, there are going to be scenarios further on down the road when we get into more advanced topics like in service provider where you're going to use the actual directly connected interfaces as a transport address. You don't have to do the loopback, but it makes the most sense to do so. And you can change that at the interface level when you do the config. And it uses TCP port 646 for doing the communication between your devices. It implies that peers must have routes to each other's transport addresses, for example, and their loopbacks. You don't have to do that though. So transport addresses can be modified but normally not needed. So like IGP hardcoding the router ID is recommended. So there could be issues with forming an LDP adjacency if there's a reachability issue. So a key thing here is if your IGP is fully functional and fully converged and there is no loops, then LDP should have no problems doing its job. When it comes to advertising labels, once the LDP session is established, label is advertised for the FEC. The forward equivalency class is what FEC stands for. So it's a label to IPv4 prefix mapping. So a route and label number binding. Label distribution can be implicit or explicit. which means you can do an unsolicited downstream versus downstream on demand. Depends on the implementation and config options. Typically speaking, we're going to be using a downstream on demand. Now, you can do unsolicited downstream, and I to be 100% honest with you, I don't remember the differences between the two. But the idea here is, actually I take that back. We are going to be doing an unsolicited downstream. So what that basically means is we're going to be advertising whether they want it or not. Where downstream on demand is you're asking for the update from your downstream neighbor. Essentially is what that comes into play. So we're going to be doing unsolicited downstream. We're going to do full label propagation to all of our neighbors regardless of who they are, just because of the fact that that gives you full propagation of LDP, your label distribution, database, all that good stuff that goes along with that. There are scenarios when you get more into how LDP actually operates, where you can limit what labels are advertised and do specific label bindings and static labels and a bunch of other stuff. Like there's LDP IGP synchronization, there's LDP authentication, a lot of advanced capabilities for LDP if you want to get into that. So back when I was studying for the CCIE, this is probably 2013, 2014, when I was starting to dive into how LDP actually operated. We would, the way I was taught it originally was just a very basic deployment. You wanted just LDP to be up and to form adjacencies and then do label propagation. That was like, literally the only thing we cared about. So as time goes on, you can learn more about that, but that's going to be more service provider centric. So how you control label distribution, inside the SP core. We'll talk about that more in detail when we get into the SP series down the road. But right now, enterprise is going to be way more popular. So just be cognizant of those things. Labels could be advertised for some or all routes. Cisco by default is all IGP routes. So really only the /32 loopbacks matter. And this is what I was talking about, where you can do some label filtering where you do your /32 only propagation. So that's an option too. But that, again, that's more of a service provider series specific topic. And you can specify a label range. Now by default, LDP is going to advertise starting at label 16 and going up incrementally until it has associated a label for everything internally. And we'll see how, going back to the original video we did for the MPLS section, this is going to be what they refer to as the transport label. So LDP is building the transport label database, not the VPN label database. And we'll see the difference as we start to build out LDP, or build out the MPLS VPNs. So you can set a range for your labels on a per device basis. So here I've got it detailed out as R20 could assign 2000 to 29.99, and then you go to 21, which would be 2100 through 21.99, so on and so forth. So so that's essentially one of the things you can do if you wanted to associate labels that are going to be specific to the device's ID number, and you could have a range there. That's something you could probably do. In segment routing, it works similarly. You can create a segment routing global block and go from there, and then you can set a local label for the device. But segment routing is going to be, again, service provider specific. The POP label means the destination is directly connected. No label means the destination doesn't have an allocated label assigned. This could be a misconfig or a transport issue. So we'll take a look at that more in detail later. I'm not going to try to explain things to you without a visual. When we're talking about a particular thing, I'll explain the step-by-step process that it comes into play. So when it comes down to LDP configuration, you enable CEF, Cisco Express Forwarding, and this is required in order for LDP to work. Should already be on. Agree on the label protocol. So MPLS label protocol, and then should already be LDP by default. And recommend to define the router ID, MPLS LDP router ID. And there are two different ways that you can enable LDP. You can either enable LDP underneath the IGP process, so MPLS LDP autoconfig, or you can turn on interface MPLS IP and go about that route. From a verification perspective, you can verify the show MPLS interfaces, which interfaces are enabled for MPLS, show the MPLS LDP sessions, so the neighbor command, verify the label forwarding information base with the show MPLS forwarding table, and then troubleshooting LDP adjacencies, debug MPLS LDP transport events. There are additional capabilities. You have session protection, you have LDP IDHP synchronization, you have auto configuration, so on and so forth. And we'll talk about VRFs in an upcoming video, but that's essentially where we're at. So with that being said, you and I are going to go ahead and begin our configuration of MPLS, or setting up LDP. So let me go ahead and log into this bad boy and go from there. Give that a second to load. So the process is actually going to be relatively straightforward. Configuration wise, it's not going to be very difficult. We're going to start on iOS, and then we'll dig into iOS XR and go from there. Alright, well, so I had a small problem. As you I paused the video, and I actually ended up having to reboot the entire environment. So I just took a few minutes and I rebuilt IS to IS. So before I would actually even begin configuring LDP, I would verify operations. So let's go check out router 64. And first thing I'm going to do is do a quick show IP route and just verify that I have reachability. So that's going to be the first thing. What we really need to have in order for LDP to operate the way we need it to is all of the loopback addresses for all the devices inside of the MPLS service provider need to be reachable. So 30, 31, 32, 46, 47, 65, and 66. They are all there, which is what we want to see. So in this particular case, the loopbacks that we care about are going to be 65, 66, 46, and 64. The provider edge routers. Those are the actual loopbacks that we care about. So what I'm going to do is I'm going to do a quick ping to 10.0.0.65, sourcing from loopback 0. If I can ping it, that's a good sign. Let me go ahead and ping 66. Perfect. And then let's go ahead and ping 46. Excellent. So that's what I really need to have in place is that. I need to make sure all of those capabilities are squared away, that I have loopback to loopback reachability from any one PE to any other PE router. If I can do that, that means I've done everything that I need to. Now, in order for LDP to work correctly, we're going to turn LDP on. So I'm going to show you guys how to do this on iOS first, and then we'll do XR later. Configuration wise, and we'll start this on router 30. There's a couple different ways to do this. So underneath here, we have the ability of going down here, and we have this, I believe, I will have to turn on, the command is right here, is MPLS, LDP, and then auto config. Now, I believe I'm going to have to turn on wide metrics for this as well, but for the sake of argument right now, I'm not going to do that. Now, I'm going to jump over to 31 and do the exact same thing. So I'm going to go router, IS to IS, MPLS, and type in MPLS LDP auto config. Now, that should form an adjacency with 30, and it does. Now, this information right here, obviously, is the loopback address of R30, and then we have this :0. That just simply means that we are using the main label database. So there is, if you had specific platforms that could support LDP at the line card level, then that would give you a different line card label database. But that's not the case here. So that's basically how that comes into play. So we're going to go ahead and just go options, session options, and turn off the what is it? Terminal. Yeah, audio bell. I'm going to turn that off. I wish I could turn that off globally, but anyway, I'm going to go over to 32, and I'm going to go to router MPLS, or sorry, router ISIS MPLS, and then LDP MPLS LDP auto config. And now I should form an adjacency with 30 and 31, which I do. Perfect. So that's basically what we want to end up happening. So fairly straightforward so far. Now let's go do 64, 65, and 66. But what I'm going to do is I'm going to enable this at the interface level. So in 64, I'm going to go to global config, interface gig 1, and type in MPLS. What is it? The command I forgot. The command is interface MPLS IP. That's right. So we have MPLS IP. And so what will end up happening is I'll form an adjacency with 30, and then I formed a peering with 64. And then we'll go to 65, and we'll go to router, ISIS, MPLS, MPLS, LDP auto, and the same thing with 66. Router, ISIS, MPLS, MPLS, LDP auto config. So there's that. And then we're going to go to XR46, log in as Rob, and go to global config. We're going to have to go underneath router, ISIS, MPLS, and we're going to type in here under globally, we'll go down to MPLS. Actually, we're going to have to go underneath address family IPv4 unicast, and then underneath here, we do MPLS, LDP, auto config. Now there's an additional step we have to go through here. We have to type in MPLS, LDP, and hit the enter key, which turns on the capability. So if we do a show config, we have to turn on the feature globally. And then I'll go ahead and I'll commit that config. So that should form an LDP adjacency here with 30, and there it goes. And we'll do the same thing with 47. So I'll go Rob, Cisco, router, ISIS. You can do it at the interface level here too, and it's MPLS, LDP, and then it is interface. In this case here, it's going to be gig 0 like this, and gig 1. And then I believe that's all you have to do here. I don't normally do it that way. So 30 and 31 should trigger here momentarily. 30 and 31 should both trigger a 47. Okay, so you've seen it both ways. So let's go ahead and jump down to 30. And we're going to do a show MPLS LDP, show MPLS interfaces. So we can see which interfaces are enabled for LDP, which all of them are. And then we're going to do a show MPLS LDP neighbors. And this is going to give us information as to who we're talking to. So we're going to see that we are paired with 31. And we can see the information going back and forth. We're using downstream on demand. The identity sources and all that good stuff that goes along with it. If we do a show MPLS LDP bindings, we're going to see all the label values that come into play with that. So there's a lot of label bindings that we're learning about. If we do show MPLS forwarding table, we're going to see our actual forwarding instance. Again, what we care about is going to be the loopback addresses. So there is a way to optimize this to get rid of all the /24s, but for right now, that's okay. Now, the way that you want to look at this is all these labels right here are local, hence the term local label. Whenever you receive a label in from another device, so we're here on 30, let's say we get a label 64 sends traffic to us, we receive it on gig 0/3, and we learn label 20 in, right? Well, in that particular case, we learn label 20 in, and there's no label outgoing, which means we're popping it. The concept of pop means that we are directly connected to that device. That's what that means. Any other locations that we would need to jump through to somebody else is where this would come into play. So 65 and 66 are far enough away. They're one hop away, so they have to go. We have to go through 31 to get there. So if I was to go to, say, 64 and do a show MPLS forwarding table, we should have, for the majority of our entire environment, we should have labels getting to where we want to go. Now, because of that, if we look at trying to go to 66, right? Notice how we have the incoming, the local label is 22, and the outgoing label is 22. You might say, well, how is that going to be? How is it going to differentiate that? And the easy way to explain this is local to the device. This is what was advertised. So if we look at 30, and we go over to 30 for 66. For 66, right, we can see that local label is 22, outgoing label is 22. Now let's jump over to 31, because 31 is what advertised that to us. Jump out of global config, do a show MPLS forwarding table. Notice how here on 66 it's 22, right? Now if we go over here to 66, and we jump out of global config, do a show MPLS forwarding table, notice that he doesn't have an entry here, right? 66 doesn't show up, but if I do a show MPLS LDP bindings for a particular address, so 10.0.0.66, 32, the local label, right? The local label is telling me that it's implicit null, so it means it's pop. The remote binder, 31, so R31, associated label 22 for this, which means this will be my destination label. So if I go over to 64, and I do a trace route to 10.0.0.66, sourcing from loopback 0 numerically, notice how 22 is my destination label, because that's the label that 31 advertised to us for it. Same thing with 65. 65 is using 21. Now, what we could do is we can optimize this a little bit. We can go into MPLS, into the routers, and we can go say, hey, I want to have a specific MPLS label range per device. So let's go ahead and do that real quick. Let's go to 66. I'm going to go to global config and have MPLS LDP label, MPLS LDP label range, and I'm going to come in here and I'll just do 6600 through 6699. Okay, so now what's going to end up happening, if I do that, then what I should start to see is on 31. Notice how there's the bytes label switched? That means that there's traffic going back and forth, so we're doing some trace routes and pings and whatnot. All that stuff is triggering. And if I have, in order for this to push, I have to actually update the label adjacency. So if I do a clear MPLS LDP neighbor star, and I hit that should clear the adjacency. And now if we go back to 31, it's up again, but I should see, I might have to clear it here too. Clear MPLS LDP neighbor. Let's see if that makes a difference. There is a way to get this to trigger. Because what I want to have happen is I want 66 to get its own data, to be a different range. So let's go, and I can change this on a regular basis to everybody else. So what I'll do is I'll copy this right here, we'll go to 65, and we'll do this, and we'll say 6500 through 6599. And I might have to do a clear MPLS LDP, no, clear MPLS, IP, no, I'm actually not sure why, clear MPLS, LDP, neighbor, SAR, I mean, there is a trigger for this, for it to learn the new label bindings. I might have to turn MPLS, you know what, I think about that now, I might have to turn MPLS off first. Because I'm thinking back that it's a turn it off, turn it back on again. So let's do that real quick. Let's go ahead and finish out setting up the range, 64, let's go back to 64. We'll copy and paste this one in here, we'll do 64, like that. And then we will turn MPLS off and then turn it back on again. So let's go to 32. Go in here and do a 32. And then to turn it off is simple enough too. You go router ISIS MPLS, type in no MPLS LDP auto. So that'll take the adjacencies down, and then you start it over again. And so do show MPLS forwarding, and now the 3200s are coming across. So that's essentially what you do. So we'll grab this label range for 31 as well. I forgot about that before. Usually I'm pretty good about remembering that, but sometimes I forget when I say that I'm going to do something. Let me go ahead and just set all the label ranges real quick, and then we'll update them, just so that it's easier to determine who's doing what. Because as we're coming through, it'll be easier to see who's doing what. And then we'll do, over here, we'll do the same thing. We'll log in, we'll do MPLS, LDP, and then we'll do the label, there's I think it's address family, IPv4, and then label range, no, it's MPLS label range. In this case here, I'm going to do 46,000 through 46,099. I'll commit that change real quick. Same thing on 47. The MPLS label range is 47,000 through 47,099. We'll commit that change real quick. Now what I'm going to do is on 30 and 31, I'll go to router ISIS MPLS and then no MPLS LDP auto. And then I'll just pull this command out. Alright, so do show MPLS forwarding, and now the label bindings are showing it the way we want them to. Now, what's cool about this is, and I don't think I cleared it here, so I have to go to show run pipe section MPLS. The label range has been set, router ISIS MPLS, no MPLS LDP auto, and we'll put that back in. Okay, so do show MPLS forwarding. That's been set. Now if we go back over here to 30, I may have to clear it again because I'm seeing 22. So let's do that again. We'll turn it off and we'll turn it back on. Right? And I would expect 22 to change. like it did for, well, it isn't changing for everything. So, but let me go ahead and finish bouncing these guys, and then router ISIS MPLS, and then no MPLS LDP auto. And we'll do that. Same thing here. No MPLS LDP auto. MPLS LDP auto. I already bounced that one. So do show MPLS forwarding. Let's go take a look at 64. Do show MPLS forwarding. We're going to need to go to the interface level, so interface gig 1, and type in no MPLS IP. And then we'll turn it back on here globally. Now this one here, this little pop-up you see, it says no router ID is available for Atom to use and will impact pseudo-wire virtual circuit, or VC. Atom is what they refer to as any transport over MPLS, because MPLS is multi-protocol label switching. Therefore, there's no router ID. It's a temporary glitch. No, it's a temporary issue because of the fact that we didn't have MPLS applied. So no big deal there. So I'm going to go ahead and do show MPLS forwarding, and now we have all the labels bound. So this is what I'm expecting to see. I'm expecting to see on 64, I'm expecting to see 30s coming in. So we'll go ahead and balance all of that real quick. So go to global config, interface gig 1, no MPLS IP, and then MPLS, or did I do show run pipe section MPLS, router ISIS MPLS, no MPLS LDP auto. It'll tell you if there's a problem. Now you can turn it off at the interface level with no MPLS LDP IGP auto config. Yeah, that's a lot. So, and then it'll come back online. We'll do the same thing for 66. I forgot about that there. So interface gig 1, no MPLS IP. We'll type in no MPLS LDP IGP auto, just to show you guys what that command looks like. So we're turning LDP auto config off at the interface, at this interface. We're going to go and turn it back on. So we should see that. And so do show MPLS forwarding, and now we're starting to see things coming in the way we expect them to. Now 46 will be a little bit different. Do show MPLS forwarding. So what we're going to go do is, and I'll talk a little bit about why these labels come in at the range that they do versus the range that all the iOS routers come in at a much lower value. I'll talk about that here in just a minute. But do show run router ISIS. So I'm going to go to here and say no commit it, and then pull that out and then commit it again. So that should trigger that. And on 47, do show run MPLS LDP. We have to go to MPLS LDP and no, and pull the interfaces out and then reapply them. And there's that. And there's that. Okay. Now that that's been done, there we go. Alright, so now that we have this fully operational again, we're going to do a show MPLS forwarding table again, and now we have all of our connectivity where we needed to, actually this one didn't get it configured. So MPLS label range 47, did I not do that? I might actually, hold on, do show run pipe section MPLS. Begin MPLS. Uh-oh, did it crash on me? '47 might have crashed. 30, 31. Yep. 40 down. Okay. Well, needless to say, I'll have to see what's up with that one. But if we go back to 46, we do show MPLS forwarding. Well, this one didn't take it either. Do show run router ISIS. Show run real quick. Let me just double check the config. Dump request. Why is that? Interesting. Both devices are giving me a hard time. Okay. Well, that's cool. I'll reboot them and see what happens. Let's go ahead and do that real quick. I'll stop this one. So for iOS XR, they have a different label range because of the fact that they start at 16,000 and go up to 24,000, and then from 24,000 on, they use, there's two different label blocks available on XR out of the gate. You've got segment routing's global block, so 16,000 through 23,999. So that's going to be an 8,000 label block. And then you have the 24,000 through, I think it's 1,050,000, I think. So we have that. So essentially what ends up happening here, and momentarily, let me go ahead and just knock this out real quick and see what's going on here. Reboot this guy. The issue that comes into hand with this is that because there's a segment routing global block involved, that's why it starts at 16,000 and works its way up to 24,000. So in that particular case, that is the reason why the label range starts there. But you don't really need to be too worried about that. You're never going to get tested on segment routing outside of the service provider exam. Did this one? Oh, it crashed. That's what happened. So, 30, yeah, 47, 31, because I booted it. So we'll just wait for that one to come back online. Did that one? Okay, see, it looks like it fixed itself. Do another show run. Should I worry about it? Yeah, I think I'm going to have to reboot this guy too. But anyway, that is why the MPLS label range is like that on XR. You don't really care too much unless you decide you're going to go on the service provider track, and that's the direction you want to go. And then we'll cover segment routing in more detail in that section. But you know, for right now, LDP is the labeling mechanism you guys need to be familiar with. Beyond that, there's really not a whole lot more for us to go into. MPLS is running the way we want it to. So if I was to go back over here to say 46, and let's just see if these guys are, let's go to 46, I'm sorry, 64, and let me jump out of global config and do a trace route to 10.0.0.65, sourcing from loopback 0 numerically. We take 3005 and 3105, which means we're passing through router 30 and 31, and we get to 65. If we go to 66, it's going 30,006 to 3106, doing the exact same thing. So at least we'll know the path that it's taking as it's going there. So that's exactly what I'm looking for you guys to be able to see. So it's like 30 and 31 are. So let me go ahead and bounce 46, see if that doesn't fix that problem, and see if that fixes it. Worst case scenario, I blow the device away and I rebuild it. But if not, you know, no big deal. I can always work with that at a later point in time. But as it sits, these are some of the issues you run into when you're labbing stuff up, as stuff gets hung up. So that is pretty much MPLS LDP and how it comes together. So that's one of those key characteristics where you're just going to need to know the basics of how to get it working. Now, we are in step 2 of building our MPLS layer cake in the MPLS section. There's 3 sections to building MPLS, the layer cake that is MPLS. So the third one is going to be spinning up BGP. Once we spin up BGP with the VPN v4 address family, we'll be good to go there. That'll be building the core network up and running. Then we'll be able to flip over to the MPLS VPN section, focus on the VRFs, focus on the PE to CE routing. Once we have that done, we'll be in a really good spot to move forward with connecting to our other devices and being able to interconnect the major locations. We'll be able to connect 58 and 59 to these PE routers. We'll be able to connect 24 and 23 appropriately, and then the remote sites as well. So it'll come into play as we go along. If you guys have any questions, comments, concerns, feedback, please leave that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.